Looking at example 3 on section 5.3. So we've got a car that is in motion, and its motion is governed by that formula right there. This is the number of feet away from its starting point at any time t. Okay? So the first thing it asks us to do is to find the velocity of this car. The velocity is the derivative of the position function. So that's how we get that. We just take the derivative of the position function and we get that. And then we went ahead and factored this because we're going to have to use the factored form later on. And then we're also asked to find the acceleration of this car at any time. And we have to remember there that the acceleration is the derivative of the velocity, or also the second derivative of the position function. So we just look at the first derivative, take another derivative and get that, and we'll go ahead and factor that as well. So for part C, we're asked to find the time intervals for t positive when the car is going forward or backing up. So the car is going forward when it has a positive velocity, and it's going backwards when it has a negative velocity. That's the convention that we typically use. So what we need to do is figure out, well, where is the velocity 0, and then we'll decide, is it positive before 0 and negative after 0, or vice versa. So, or not 0, the place where the velocity actually is 0. So the time when the velocity is actually 0. So what we want to do is take that velocity function, and we're going to set that equal to 0, and then solve for t. And this will tell us when the car stops, and then either before that time or after that time the car might be moving forward or backward. So we get the factored form of the function, t minus 4, t plus 2, set that equal to 0. That gives us t equals 4. And it also gives us t equals negative 2, but that one doesn't matter because it says for positive times only. So what we're seeing here is the velocity is 0 when time is 4. That means after 4 seconds the car has come to a total stop. And that means that before that it was either going forward or backward, and then after that it might have been doing the opposite thing. So what we want to do, again, this is what we would call a critical number for what we've been talking about previously. So what do I want to do? I just want to figure out, well, what was the velocity before time 4 and what was the velocity after time 4? We could set up a table to do this, but it's really, since that's really the only critical number, all we have to do is just say, well, let's pick a value before 4 and see what the output was. So what was the velocity at time 1? Was it positive or negative? So we can come back up here to the factored form and look at that. If I plug 1 in there, 1 minus 4 is going to give me a negative number. 1 plus 2 is going to give me a positive number. That tells me that when t was 1, the velocity was negative. So the car was actually backing up for the first 4 seconds of its travel. And then also notice that if I pick a number on the other side of 4, say 5, what happens? Well, if I plug 5 in there, now both of those terms are positive, and so I get a positive value for the velocity. So what does that tell me? That the car was backing up before time 4, because the velocity was 0 at time 4, that's what we just found here. It was backing up before 4, and it was going forward after 4. We picked these values. These were what we would call test values on our tables from what we'd seen before. Okay, so that answers that question. If we want to write that down, it would be 4 going backward on the interval from 0 to 4. And I guess I should probably do that kind of parentheses there. It's backward on that interval and forward on the other time interval. And since there's no limit on the upper limit on the time, we just have to put infinity. So obviously this car is not going to be driving infinitely long, but mathematically speaking, that's where it's going forward, because that's where the derivative is positive. The velocity is positive. Okay, now to find the intervals where the car is speeding up or slowing down, for part D, a car is, or any particle will be speeding up if both the velocity and the acceleration have the same sign, and it would be slowing down if the velocity and the acceleration have different signs. So what we want to figure out first is where is the acceleration 0? So notice that if I take that acceleration function and set it equal to 0, I find that t equals 1. Okay? So just like we did before with the velocity, I'm going to do the same thing with the acceleration. I'm going to find, okay, well, what was it doing before time 1? In other words, what was the sign of the second derivative? What was the sign of the acceleration? So again, we can pick a test value here. Suppose I pick, let's say, t equals 2, and I find, well, what was a of 2? Okay, well, that means if I plug 2 in there, I'm going to find that that's a positive number, right? So in fact, really all I care about is that it's greater than 0. So the car was had a positive acceleration after time t equals 1. And then you'll notice that if you plug in a number that's less than 1, then that's going to be negative. So you can say like a of 0 was negative. So what does that mean? Acceleration was negative before 1 and it was positive after 1. So now what we want to think about is when does the acceleration and the velocity have the same signs? Okay, so notice on the interval from 0 to 1, what's true about the velocity and the acceleration? Well, from 0 to 1, we found that the velocity was positive. I'm sorry, the acceleration was positive. No, I'm sorry, it's negative because from 0 to 1, we've got a less than 0 acceleration there. So for 0 to 1, the acceleration was negative. And what was true about the velocity on that time interval? Well, if we come back to the velocity, on the interval from 0 to 4, the velocity was negative, right? So velocity is also negative. So what is that telling us? On the interval from 0 to 1, they both have the same sign. So if you can imagine a car, something that's going, has a velocity in a particular direction, and it also has an acceleration in the same direction. Well, acceleration means that the velocity is changing. So if you've got both velocity and acceleration having the same sign, that means it's going to be speeding up in that direction. So it's speeding up in the negative direction. But nonetheless, it's speeding up. So that's our conclusion there, speeding up. And then let's check the other time interval that we saw here from 0 to 4, or sorry, from 1 to 4, because we already checked from 0 to 1. From 1 to 4, let's see what the signs we have. Well, after 1, we found that the acceleration was positive, so a of t is positive. And what else? So from 1 to 4, what sign did the velocity have? Well, it hasn't changed, right? Because the velocity had a, up until 4, it was, well, from 0 to 4, it was always negative, right? So the velocity is negative still. It hasn't changed. So what does this tell us? Acceleration positive, velocity negative. Well, that means the velocity is, the car is going in that direction, but since it's accelerating in the other direction, that means it's actually slowing down. So it's slowing down on the second interval from 1 to 4. Now what's it doing after 4? Let me make sure that we have enough room here. I'm going to raise this up a little bit. Okay, so on the final interval, after 4, what is it doing? Well, the accelerations hasn't changed. It's still positive. In fact, it's positive for all numbers after t equals 1. So the acceleration is still the same. But now, after time 4, the velocity has now switched again. So we said that after 4, the velocity was positive. So now what do we find? Now the velocities and the accelerations again are pointing in the same direction, but in the other way. But it doesn't matter which way they're going. As long as they're the same sign, then the car is accelerating. So again, the velocity is this way now. It's positive. The car is going that way. Acceleration is also pointing in that direction. So it's going that way and it's accelerating in that way, that means it's speeding up. So the car is now speeding up again, only in the opposite direction that it was before. So this is the way you want to approach this type of question. If you're asked to find the intervals where something is speeding up or slowing down, you really have to decide what's happening with the signs of the acceleration and the velocity. If they're the same, then the car or whatever it is will be speeding up. If they're different signs, then the particle or whatever it is will be slowing down.